Okay, so today I want to talk about how to automate the backups of a EBS volume attached to an EC2 instance. Amazon provides some nice functionality through CloudWatch events to perform the actual backups, but there's really no functionality for pruning those backups. So we're also going to create a Node.js-based Lambda function that will run at the same time the backup utility runs that will prune the backups older than 5 days. This way we keep the last 5 days worth of backups and we don't have to worry about our disk space usage getting out of hand and being billed for stuff that we really don't need anymore. So the first thing we're going to do is actually create our first event that backs up the volume attached to the instance. So I already have an EC2 instance created here. It's a T2 micro instance, and it has a simple 8 GB volume attached to it. So here's the instance. We can see the volume that is attached by clicking on volumes over here, Elastic Block Store volumes. And this is the volume that we have attached to that instance. So this is the one that we're going to actually be backing up. So let's go into our CloudWatch service, because that's where we're going to perform our backups. Go to Amazon CloudWatch, and over here on the left-hand side, we'll see events, and under events, we have rules. Rules is what we're going to click on. You can see we don't have anything here yet, so let's go ahead and create a rule. We want to schedule this, and we're going to use this like a cron expression. Linux cron allows you to schedule jobs on a regular basis. So what we're going to do here is we're going to say 0 for the minute and 1 for the hour. So that'd be 1 a.m. Every day of the week. Okay, and we can see the next 10 trigger dates, February 17th at 1 a.m., February 18th at 1 a.m., so on and so forth. And these times are GMT. They are not your local time, they are GMT. Once we have that in there, we can go ahead and add a target. The target we want to choose is actually a built-in target that Amazon provides for us. And the first one is already selected, create a snapshot of an EBS volume. When you select volume ID here, the only one we have right now is this. If you have a lot of volumes, you may want to type it in or copy and paste from the volume screen in the EC2 console. We're just going to go ahead and click on this one here. We're going to hit configure details. Let's give this a name like EC2 backup. We'll skip the description for now, and we're going to start this in an enabled state. Amazon does need permissions, just like everything else. So we're going to use a basic built-in targets role. I'm going to load this up here. This is kind of pre-filled out already. We're going to create a new IAM role to handle this. We can view the policy document if we want to. Basically, this allows CloudWatch to describe our instance, reboot instances, stop instances, terminate instances, and finally create snapshots. Depending on how your EBS volume is mounted, it may need any of these permissions. And then lastly, this resource option here says it can do this with any instances or any snapshots that we have. You may want to edit this depending on your level of permissions. But for this simple example, I'm going to leave this as any resource. So we click allow down here at the bottom. And this takes us back to our CloudWatch event rule. We're going to just go ahead and hit create rule. Now that's done. Oh, let's see, validation error. EC2 backup and name failed to satisfy constraint. So we can't use spaces in our name. So let's go ahead and put an underscore in there. Create rule. And there we go. We have a EC2 backup rule that will run at 1 a.m. every day and will back up this volume that we have attached to the instance. So that was the easy part. The hard part now comes in how to prune those. So for that, we're going to go over to our code editor here, and we're going to start creating a Lambda function. The runtime environment that Amazon Lambda runs for Node.js is 4.3.2. So we're going to go ahead and switch over to that real quick. Use 4.3.2 64-bit. NVM is a Windows utility. It's a Node version manager. There's similar utilities for Mac and for Linux. I prefer this one just because it's written in Go, so it's completely separate from Node, and it uses some nice little utilities to make sure that your current environment uses that node. So if we type in node-v here, let's run this one more time. There we go. Now if we do node-v, we get version 4.3.2. All right, so we don't have any files here. Let's go ahead and create a new file. We'll just name this index.js. File name doesn't really matter because really we're just going to copy and paste this code into the Lambda console, but we're going to give it a .js ending so we get some nice syntax highlighting. If you're not familiar with Node.js, I definitely recommend doing a really short tutorial on Node. But most of the stuff here is plain old JavaScript. There's very little in the way of actual Node type stuff. First thing we're going to need is the Amazon SDK. Now this is provided for you in the Lambda runtime environment for Node on Amazon. So you don't have to worry about including this Node module with your application or with your script. Amazon does provide it for you. As of this time, the current version, I believe, is 2.7. So let's go ahead and bring that in. All right, and that's going to allow us to start using the Amazon information here, or the Amazon API. We also need to create a EC2 class so we can access the EC2 services. EC2 is the one that handles all of the snapshots, the describing of snapshots, deleting of snapshots, so on and so forth. So let's create an EC2 variable here. And we also need to specify a specific region. Here in our case, we're using US West 2, the Oregon region. Okay, so we have 3 different operations that we're going to kind of need to perform here. So I'm going to go ahead and just stub these out real quick so we can kind of see what the flow is going to be. We're going to have a function that gets our snapshots, and this function is going to take in a volume ID as an argument. We're also going to need a function to filter out the snapshots. So get snapshots is going to get every snapshot for this volume. We'll have a filter snapshots function that will actually get the snapshots that we actually need to prune. So anything older than 5 days. And this is going to take an argument of the snapshots that we previously received. And last, we need a function to actually go through and delete the snapshots. Now, of course, we could do this in all one linear programmatic type way, a functional type way. What we're actually going to do here is keep these separation of concerns away from one another. So it's really easy if we needed to test this or to debug what's actually happening here. All right, and lastly, for the node environment, we're going to need a exports variable. So exports handler equals, and we're going to do a arrow function here, a lambda arrow function. We're going to pass in the event. This can be any custom event data, and we'll show how we use this a little bit later. The context, and context provides information about the lambda function itself. And lastly, we have a callback argument, and we're going to use that to indicate that we've actually completed deleting the snapshots, or if we've had an error in deleting the snapshots. All right, so the first thing we're going to do in here is we're going to get our snapshots. And granted, this isn't going to work. This probably isn't going to make sense until we actually start filling out these functions. But we're just going to go ahead and start populating that in here now. So like I said, get snapshots takes a volume ID as an argument. We're going to use our event parameter to this function to get the volume ID. So we're going to get event volume, oops, lowercase on that, volume ID. And then, and if you're not familiar with the then, you'll see how we use it shortly. This is promises. You can see in the type hint that's in here, the function t, promise t result. So we use promises in here to kind of manage the asynchronous flow of all of the Amazon calls. JavaScript calls tend to be asynchronous in nature. You can typically provide callbacks, or you can use promises. I prefer promises because it makes the flow read a little bit better in the code. So we have get snapshots, then we will filter snapshots. And then finally, we will delete snapshots. And after here, we will have one more then, a small arrow function of callback, and this will indicate that we've actually completed. And to wrap everything up, in case there's an error, we're going to do a small arrow function again and do a callback with our error. The callback parameter takes 2 arguments. The first one is an error. The second one is a success message. If you pass null or call it with nothing, it means successful. If you call it with an error or a message in the first argument, then that means there's some sort of error, and Lambda can notify you about that. So that is our event handler. So we don't need to do anything more in here. Now we're going to get to the good stuff of actually getting our snapshots, filtering our snapshots, and deleting our snapshots. So to get our snapshots, we need to call the EC2 API. We're going to actually describe snapshots. So we're going to do a return EC2 describe snapshots. And this takes a couple of parameters. The one that we're most interested in is the filters parameter. And this will allow us to filter out the snapshots to the specific volume that we're looking for, as well as a description, an empty description, as a matter of fact, because that's what Amazon uses when it creates the backups. So we want to make sure that we don't capture any manual backups that we've created of those snapshots. So we're going to do filters here. Filters is an array of objects, with the objects having a name property, and we're going to call that one volume ID. And we also have a values property. And values is an array, but in our case, we're only going to pass it the volume ID, and that is going to only return snapshots that belong to that volume. The second one that we're going to do, we'll do name and description. And the values for this one is just an array with an empty value in it. All right, that's all we need to describe snapshots. This will retrieve all of the snapshots for this particular volume that do not have a description or have an empty description. We're going to follow this with a .promise call and then a then call to pass in the results. Let's call this results. And from the results, we're actually going to return the snapshots. So what the results actually look like, I'll put a comment in up here. So our results looks like a object, and that object has a property of snapshots, and that snapshots is an array, and within there are all of the snapshots that we received. So we're just going to return the actual snapshots so that once we get to filter snapshots, that's what we have to work with. So that receives all of our snapshots. Let's go down to filter. We need a cutoff time, so let's create that variable here. That will be a new date, and we're going to set that date to another new date minus 5 days. Okay, so this creates a new date variable 5 days in the past, and this is what we're going to use to filter out the snapshots. So we're going to create an array of snapshots that we actually want to delete here. And we're going to iterate through all of those snapshots that were passed in from the get snapshots call above. We want to check if the snapshots, whoops, there we go, the snapshot start time is less than our cutoff time. And if it is less than our cutoff time, we're going to push that onto our array. Oh, and I noticed a quick misspelling here. Let's change this to 4. There we go. And now we're going to just return the toDelete array. So this is an array of snapshots that will then be deleted by our delete function. So let's go into our delete snapshots function here. We're going to kind of keep track of all of the snapshots that we delete. And the reason for that is because we don't want to successfully return the promise from this function until all snapshots have been deleted that we need to delete. So let's do let deleted be an array. And we're going to, again, iterate through all the snapshots that were passed in. And we're going to push onto the array. Oops, push, if I can type. There we go. We're going to use our EC2 API again, EC2 dot delete snapshot. And we need to pass in the snapshot ID. So here we go, snapshot ID. And we can get that ID from our snapshots array. Let I in snapshots, there we go. Snapshots I dot snapshot ID. There we go. And on this, again, we're going to do dot promise. And then we will close off. Oh, what did I miss here? This needs to go inside here. There we go. All right, so now we have a array, a deleted array that contains promises for all of the snapshots that we want to delete. And finally down here, we're going to return promise.all deleted. So promise.all will return a successful response once all of the promises in this array have completed successfully. Once those have completed successfully, then this then will run here, calling our callback, meaning it was successful. If any error occurs in any of these, it will fall into our catch block right here, which will fire off an error for us. So now that we have our function here, we're going to go ahead and copy this, and we're going to go back over to Amazon here. Now in Amazon, before we can create this Lambda function, we need to create another IAM role for that Lambda function so it has access to our snapshots. So let's go into IAM, and we're going to go to roles and create a new role. So we'll call this Lambda backup prune. There we go. And we'll hit next step down at the bottom here. We want to choose this service role right here. AWS Lambda allows a Lambda function to call AWS services on your behalf. We're going to hit select. We're going to skip this because we're not going to choose any pre-made policies. We're actually going to create our own inline policy. And we're going to hit create role. Once this role is created, we can open up the role. We're going to go to inline policies and create an inline policy. We're going to use the policy generator because this just makes it easy for us. We want an effect of allow. We're going to go through here and search for the Amazon EC2. There we go. And for actions, we only need 2 actions if you remember our code right. We have a function to describe snapshots and a function to delete snapshots. So those are the 2 actions that we're going to select in here. So let's search for the delete first because alphabetically that's where it'll be. There's delete snapshot. And now we're going to look for describe snapshots. There it is, describe snapshots. And the ARN, we're going to do a star because we want to allow this for any snapshots. We'll hit add statement, we hit next step. Here we can see a policy document that's going to be generated for us. We'll leave this policy name as is. It does have a date and timestamp on it. And we hit validate policy just to make sure this is okay. You can see up here the policy is valid, and we will apply policy. Great, so now we have an IAM role that will be applied to our Lambda function. So you notice here in our code, when we set up the Amazon API, we don't specify any access keys, any usernames or passwords or anything like that. We keep that out of our code entirely. When this runs, Amazon will look at the environment that we're running in, the Lambda environment, and it will look for any access keys that are in the environment variables, or it will look for any IAM roles that are attached to that Lambda function. So we're going to take this IAM role and attach it to our function. So let's go in here to Lambda. We're going to create this Lambda function now. Now you can see we don't have any Lambda functions currently in here, so it's asking us to get started. So we'll go ahead and do that. We're going to choose a blank function. We're going to leave this trigger blank right now. We're just going to create our function. Okay, my function name, we'll call this Lambda backup prune. Description we can leave blank. Runtime is going to be Node.js 4.3. Edit code in line is what we want to stick with. And what we're going to do is just paste our code in here. So we have all of our code. All right, we don't need any encryption helpers. We're not setting any environment variables. If you wanted to set environment variables for your access keys and secret keys, you could. And you can also encrypt them so that they are encrypted in KMS and can only be accessed by this Lambda function. We're going to stick with the handler of index.handler. You can see this exports.handler. If we had a different name here, like exports.myfunction, then we could change this to index.myfunction. For a role, we're going to choose an existing role, and we're going to use the Lambda backup prune. We're going to leave this at 128 megabytes because this doesn't need a whole lot of resources to run. In fact, 128 is the minimum. And the timeout, we're actually going to set at 5 seconds, just in case, but this normally takes only around 1.5 seconds to 2 seconds to run. For DLQ resource, we're not going to worry about this one. This Lambda function isn't processing any data that needs to be redone. If it were to fail or timeout, it can just run the next day and we'll be fine. We don't need to attach it to a VPC because we're not accessing any specific resources in a VPC, and the KMS key can be left as default as well. We'll hit next here, and we will hit create function. And there we are all set. Let's go ahead and just test this real quick here. So we can go into test up here. Okay, it wants some sample data. So what we're going to do is pass in a volume ID. And for that volume ID, let's actually go back to our, let's cancel on this real quick. Let's go over to EC2 and pull out our volume ID, and we'll just run this function real quick. It wouldn't delete anything, but we're just going to run it to make sure that everything runs okay. Here we go, we have this. Let's go back over and test. Now this does have to be valid JSON. It cannot be a JavaScript object, so make sure you have quotes appropriately. All right, and we're going to save and test. Now this is going to run, oh, and there was an error. Block scope declarations are not yet supported outside strict mode, so we have to add something to this. We're going to go right to the top here, and we're going to use strict. And we're going to go ahead and test this one more time. And you can see it runs. Oh, and there was a exception. So date.getDate is not a function. So what did we forget here? We have date. We need a parenthesis right here. There we go. All right, so let's go ahead and save and test again. Here we go, we're running. Execution result succeeded. We don't have any output because, again, down here at the bottom, we called callback with nothing. If we wanted to, we could pass in null here, and then we could say this was successful. Put some exclamation points in there. Actually, let's go ahead and be really super excited and add the 1 in there. And let's save and test this one more time. And once this runs, our execution result should be this was successful. So this completely ran. It described snapshots. It filtered them. It deleted them. Even though there's really nothing to delete, we know this all ran through without any errors. So we're going to go ahead and go back to functions here. This again lists all of our functions. So now we can take this and we can add it to CloudWatch. So let's go ahead and go into our CloudWatch services. I'm going to use a shortcut here in my history on the left. And again, we go to rules. Now we don't need to create a new rule. We can just add another trigger, or another target rather, to this rule. So we're going to go to actions and edit. Let's add a target. Lambda function is selected by default. We can click our Lambda backup prune function here. We're going to configure our input, constant JSON text. So this is just like our test. So we're going to do volume ID, and we're going to paste in that. There we go. So that's going to be our input. We're going to hit configure details, and we're going to hit update rule. There we go, and we are now all set. Our EC2 backup is set to run every day at 1 a.m. GMT. It has 2 targets, a target to create snapshots and a target to prune the snapshots. Our pruning of snapshots is done with a Lambda Node.js function. It has input of a volume ID. So if you wanted to set this up in the future to prune potentially more backups, all you would have to do is add new targets for the backups, and you can reuse that Lambda function and just pass in the new volume ID. And we can see again in our Lambda function that this is an inline Lambda function. We just copy and paste it directly into the console here. We can see that this is our Node.js JavaScript Lambda function. If we wanted to add some additional configuration, we can go in here. Again, we can see the role. If we needed to change the role for any reason, we could. We can view the triggers that are in here, and our CloudWatch trigger shows up in here. We can see how often it runs. And if we wanted to monitor, we can see our invocation count, invocation duration, invocation errors if there were any, if we had to throttle or if it was throttled in any way, shape, or form. And again, any environment variables down here at the bottom. So that is it. If you have any questions, let me know.